So hello and welcome to my talk on how to build a continuous delivery pipeline with Gradle and Jenkins. So the main focus will be on Gradle, on Jenkins. Keep in mind you can build such a pipeline with pretty much any technologies that you pick. It could be Maven, it could be something else. So if you go for a team study, that's totally fine. So you can apply the same practices here to your own environments. In the beginning, I also want to talk about continuous delivery in general. What does it mean? What kind of purpose does it solve? And then we'll quickly go into how to model each of these steps that you might have in a build pipeline with the help of Gradle and Jenkins. My name is Ben Mushko. I work for Gradle Inc. I'm working very closely with many of our clients, and the need for building such a pipeline is simply there. You've heard in this morning from Jens how important continuous delivery is. And we usually help clients migrating from Maven or N to Gradle. And part of that is also building the ecosystem around the build tools, which means CI, then setting up new environments, version control, migrations, and so forth. So for anyone that doesn't really know what continuous delivery is, if that's a new term in your world, so continuous delivery is a software engineering practice that focuses on automating your delivery pipeline. So it focuses on the delivery process that you have in place from building your software in your local development environment to getting it into production, so to the end customer. So the end goal here is to have a good time to market, which is very important today. So you want to be able to deliver your software fast and frequently. Many people confuse continuous delivery with continuous deployment. So there's a major difference. Continuous delivery doesn't necessarily mean that you have to deploy the changes that you put into your version control right away after you build it. It basically just means you get it into a production-ready state, whereas continuous deployment basically means every change that you put into your version control system and that passes the right quality gates, it will automatically be deployed. So that's the major difference here. So how do you do this? Continuous delivery forms the term of a so-called build pipeline, and the build pipeline is basically the orchestration engine for all of your steps that you have that are required to actually get your software built on the developer's machine, to run the tests, to assemble it, to deploy it to different environments, to get it automatically tested, these kinds of things. So you can see the build pipeline just as individual steps that are piecemeal together to form the whole software delivery process that you have in your organization. Keep in mind that the build pipeline that I'm going to present is going to be specific to my example. So I'm going to focus on a Java project. It's going to be a web-based project. But this might look slightly different in your own projects, in your own environment. So you could imagine building such a build pipeline is different for a web application than it is for a desktop application, or if you're building a Java-based application versus a native application or Android. So basically the steps might be different. So try to adapt whatever you have in your own environment to your own needs. So that's kind of important here. That's the important takeaway. So continuous delivery, if you read that book by J.S. Humble, it says basically whenever you make a commit to your version control system, that could basically travel through your whole build pipeline, and in the end, it could be deployed. Sounds pretty scary. Actually, it is. It would be scary if you just let it travel through without putting the right quality in. And by that, I mean between each of these steps, you might want to establish so-called quality gates, and the quality gates define certain metrics that you define as a team or as a company to make sure that you don't move on in that build pipeline if you then actually meet these thresholds, these metrics. So you want to say, for example, if my code doesn't compile, then I don't even want to test my code. That really makes sense. Otherwise, you don't want to actually move on in your process. Or if the functional tests don't pass, don't move on. Or if your static code analysis doesn't pass, don't move on. So there could be many examples. And the metrics that you need for this to define such a quality gate is pretty much up to your own definition. So it depends on what you deem to be good, what your quality is or means. So let's have a look at one example pipeline here. So one thing that happens in a build pipeline in continuous delivery is that you have to have a version control system. So that's really a prerequisite, but it doesn't really mean that you have to use Git or that you have to use Subversion or something specific. Again, continuous delivery is more a practice than a tooling choice. But keep in mind that you have your code in version control. It's versioned. Whenever you make a change, you commit to it. And that usually kicks off the initial step of your build pipeline. Usually in a Java-based project, you want to compile your code. You want to run unit tests. You do this in the first step because the feedback loop should be fairly quick. So you want to know right away if something's broken. Compilation shouldn't take too long if your project isn't too big. Also, running unit tests should be fast. If you compare that to other types of tests like integration testing, functional testing, they run decoupled. They just test really a class, a specific module in isolation. So you try to mock out any kind of like external calls it makes. So try to decouple that, try to make it fast. So once you're good here, and keep in mind, there could already be a quality gate in between these two steps. So if compilation fails, you don't move on in your build pipeline. Or if your unit tests, at least one of them fails, then don't move on. You could also say if like 5 of them fail, I'm still good. That's up to your definition. I would say, no, don't move on. There's something already wrong. And then you could have other steps. These other steps could be integration testing. Usually integration testing takes slightly longer. So you want to actually integrate with a different component or with a different service. For example, you make a database call. You want to test your persistence code. This could be all done in that separate step of integration testing. At some point of time, you might want to integrate code analysis tools. In the Java space, there's Findbox, PMD, Checkstyle, and all these kinds of things that you might be familiar with. They can also hook up automatically in your build pipeline. Whether that's the third step or something in parallel, again, is up to your definition. Sometimes these analysis tools take quite a while, so you don't want to hold up your build pipeline. So you could run this in parallel or nightly, depending on how you define your quality gates. And then at some point of time, you say, OK, now I'm ready. It's all good. I know that basic tests work. I compiled my code. Now I can actually package my actual deliverable artifact. In this case, when I'm talking about a Java application, web-based, that would be a WAR file. Could be an EAR file or something else. So this step basically just makes sure that you put everything together that's needed for deployment. And part of the step also should deploy or upload, publish your artifact to a binary repository. So keep in mind, in such a build pipeline, you only want to build the artifact once. And then from there on, you simply reuse it. You push it to the binary artifact repository, and you can always access it if you need it for, let's say, different environments, for rollbacks and things like that. So you actually have a historical record of things, of all the artifacts that have been deployed with a specific version. So let's say you have it in the binary repository. Now you can actually take this guy and automatically deploy that to some sort of canary environment. I call it test here. So we automatically push it there. And then, of course, you want to automate whatever you can test as well. So acceptance tests should also be automated. So you not only want to write unit tests, you actually want to have integration tests and also the functional tests, which basically tests your application from a user's perspective. So typical use cases people run through, like I put something into my shopping cart, I want to check out, I want to pay for it, these kinds of things, or I want to create a new user. These are typical acceptance tests here. Up to this point, actually, your QA department actually didn't touch any deployed environment yet. Up to this point, everything is automated. And that's cool. We don't want to waste time of our people on just stuff that potentially doesn't even work. So now you're kind of ready. You run through your acceptance tests, and hopefully your tests are good. And you get to a point where you say, hey, now I can actually integrate it in some user acceptance test environment. That's the point where you actually let your QA guys go ahead and test it. Again, the binary artifact that we are reusing here is not rebuilt. We actually pull this off the binary repository. You might actually ask yourself, why do we actually do this? every time you rebuild the artifact, it could introduce additional problems. We want to definitely avoid that. And then at some point of time, you say, OK, now QA department ran through all the test cases that they have in place. We can now deploy it to production, make it available to the end user. So some of you guys probably have read the book Continuous Delivery by J.S. Humble. You might read it, and each of the steps are clear. But you might ask yourself, well, how do I apply these patterns, these practices to my specific environment? This looks kind of different to what I have. Do I have to use Gradle? Can I use Maven? Because that's what we have in place right now. Do I have to use Jenkins? Because that's what Ben presented here at the Gradle Summit. No, you don't. So really, it's a software development practice. The tooling itself is up to you, what you define. And of course, you can do this with Maven, but I'm presenting it in Gradle here because it's just easier to be done. It's more flexible, and there are many benefits to using Gradle to also model your pipeline here, or each of these steps. So let's talk about such a build pipeline and how you can solve this with Gradle. So for a Java-based application, the first step is fairly simple. So you just have to apply the Java plugin, which also gives you automatically the compilation task out of the box. It knows how to run tests. So if you stick to the conventions, basically you have a one-liner so far. Usually you want to add something to it, but there's really not much more to it. The priority for you as a team is that if at any point in time in your build pipeline, your build is broken, you want to make sure that you fix it. So one of the challenges of continuous delivery is not so much the tooling choice, it's more the change in culture. So if you are not used as a team to fix broken builds, if you leave them hanging for a week, you already have a big issue. And this issue you need to fix right away. So make sure if somebody checks it in, that person is responsible for also getting the build green again. That not only applies to compilation, but also to any type of test and so on. As I mentioned in the beginning, this is the initial step of our build pipeline in this case, and you want to, this is being kicked off every time somebody checks code into version control. Let's talk about integration testing. These are usually the longer running tests. That's why you want to have them as a separate step a little bit later, because you want to make sure that if the unit tests are already broken, you already know something's wrong. So don't even run integration tests. You might say, well, I now also need some sort of like environment setup because now I need a connection to my database or I need to call a web service. They're usually harder to maintain. This is just something you have to keep in mind. So how do you actually model integration testing in Gradle? So somebody mentioned, I think in another talk, that hopefully in Gradle we will have something like a notion of a test suite built into Gradle core. That's probably something that we don't want to do, but at the moment you can model this yourself. So what I personally like to do in my projects, apart from the conventions that you already have for a Java project, source main Java, source test Java, I like to keep my integration tests or other types of tests that could mean performance tests or something else, smoke testing for an environment, completely separate from the integration tests, from the unit tests. So what I do here is I set up a new source code directory, in this case called source intact test Java, really whatever you want to call it. If you want to make it more expressive, okay, you can call it integration test. That's really up to you. The key point is here that you can stick them into a dedicated location and then can set up your build to actually point to it. And you can model this in Gradle with the help of so-called source sets. Probably most of you guys have touched this already. So what we do here is we create a new source set, which we give it a specific name. This name, in this case, is integration test. And then we simply use the API that a source set exposes to point it to these specific directories. So you can see there, we point to the directory source intact test Java. And then we also have to make sure that we set up the right class path for compilation and for runtime. So that basically models our source set. And with that, we also want to set up a new task to dedicatedly run the integration tests. So in our pipeline, as you might remember, we want to run integration tests separate from unit tests. That's why we have to have a separate task here. You can see we give it a specific type. This type is test. It's one of the custom tasks that come with the Gradle Core API. And if you have a deeper look at the default test task that the Java plugin gives you, this is how we model it internally as well. You can see there, there's not too much going on. Test classes there, so we simply pointed to the output of the source set that we had modeled before. And we stick the output, so everything that comes out of the test execution, like test results, test reports, HTML, XML, and so on, into a dedicated directory as well. So you can keep everything separate, reports, execution. Did you have a test? Yep. Question? Yep.
When you set up the integration test, do you need to try to have it use the same binary that you produced in the commit test? That's one of the things that Jess Humble recommends in his book.
Can you restate the question a little bit? Give it more context.
So when you run the integration test, should you use the same binaries that were produced in the commit stage?
So in this case, integration testing, maybe what you're asking about potentially is functional tests. So you want to build the artifact just once. In this case, we just run them against the compiled source code. So we're still at a stage where we just run the integration tests. We haven't even taken that jar file and deployed it somewhere into a runtime environment. So I think we're talking more about functional tests here. But yes, in that case, you would simply reuse the same jar file that you use for automated testing, and then later on, you will also deploy that one to production. Yes, correct. And then the only thing you have to do here in your build pipeline, you simply execute the specific task. One more thing I want to mention here, many people ask about code coverage, and we have one built-in tool option in Gradle Core, which is based off Jacoco, so it's a built-in plugin. The benefit of this plugin is, or of Jacoco in general, is that it doesn't actually have to modify the source or bytecode when you generate the instrumentation of it. Again, important here, you don't actually want to modify anything that you don't need to modify. Just to make sure that you don't introduce additional issues into your production classes that you create with compilation, and then later on package it up and deploy it to production. So what it does instead is that it does on-the-fly bytecode instrumentation, so it basically just adds a Java agent when you run your actual test tasks. If you use the plugin, this is basically configured automatically out of the box for you. So there's actually not much you have to do. Apply the plugin, which is called Jacoco. It provides tasks for generating the reports, and when you run the specific test tasks, it will automatically also create the coverage. We do some extra thing here for the integration tests, because by default, the Java plugin doesn't even know anything about an integration test source set or a test task. That's why we have to create a new report task, and you can see the type is Jacoco report, which is part of the plugin, to also generate code coverage reports for the integration tests. So not only just create code coverage for unit tests, you can create the same stuff for integration tests as well. So let's talk about code analysis. It's actually fairly simple. So what we want to achieve here is that we want to get a quick health check of our code. Some tools help with that. They might have a look at your code, how it's laid out, tries to find out typical problems in code to identify problems early on. In this case, again, you can introduce quality gates, and you can also fail the build if one of the tools or any of the tools actually report issues here. Some people like to record the progress over time. So if at some point of time your manager says, hey, I want to compare our code quality from the status in March up to July, then you could do these kind of things as well. But what's more helpful in this context, I would say, is Sona Cube, a different product that you can use. It's open source, but it allows you to actually record the progress over time and then compare it based on the months or specific builds even. Just to give you an idea of how this looks like, for the specific plugins that we have in Gradle Core, PMD, it's fairly simple. You apply the plugin, and you can configure it over an extension. You can enable the XML report or HTML report depending on your needs. Similar to JDepend, so really nothing too crazy here. One thing that you can keep in mind here is that all of these tools, they automatically hook into the lifecycle of a Java project. So they will automatically attach to the check task. So whenever you run Gradle build, that will invoke check as well. And check basically also calls off to these tools here. I just mentioned, yep, one question? You could. It's up to your definition. When you say, what's the first step, like compilation unit testing? The main reason for that is fast feedback. If you run some of these tools, especially Sona, it might actually take half an hour to be done, depending on how big your code base is. It really depends on how big your code base is. So the more classes you have, the more source files these tools have to scan, the longer it will take. And there are strategies to work around that. So you could basically run this in parallel in your build pipeline. So you don't have to have this as a concrete step. You could also fork off and then later on join together. If things tend to take longer, you can do these kinds of things. Yep. Yeah, you could also set up, so what some people do for pull requests in general, they set up additional build pipelines just for a specific branch or a pull request to get automatic checks or like a sub-selection of a build pipeline as pre-tests until you actually integrate that into master. Usually the essence of continuous delivery is that everybody works on master, so you commit it to master, and then you fix it along the way. It's one of the cultural changes. If you rather want to go for pull requests, that's fine. It just deviates a little bit from the model, but ultimately you want to integrate as often as you can.
I think Sonar has built-in PMD and check styles, and so if you run Sonar, you can do that. I wonder why would you configure it as a part of Gradle?
Okay, so this is just one option. Actually, the next step is talking about Sona. And I wanted to actually say that it's actually much easier to configure whatever tool you want to use through the dashboard in Sona, and then basically also define the thresholds, the metrics, and the quality gates. And you can also configure Sona in a way that it would fail your build if the specific metrics are not met. So you can automatically put in a quality gate with the help of Sona. So I just wanted to show you the options. Usually what you see in enterprise projects, they probably want to rather go for an integrated solution that also brings together multiple projects into a single dashboard, because with these individual tools, you actually have to keep track of the reports, and comparing the results is not easy, I would say. And you have to actually store them somewhere. So you have to have a historical record of these things. So in your build, you would have to actually copy them somewhere, which you don't want to actually do. So Sona actually makes your life much easier. So for everyone that doesn't know what Sona is, so it comes with a web dashboard, which lets you view your statistics and metrics over time for each of your projects. And we also have a plugin here, which is called the Sona Runner plugin in Gradle, which automatically analyzes your project. And then it pushes the results into a database, which is centrally used by the web application as well as Gradle. And then on the web-based application, you can basically look how it changes over time. You can drill into specific tools and the metrics. So that's pretty handy here. So what do you have to do in terms of the Gradle configuration? It's actually fairly simple. So you apply the Sona Runner plugin, and then you just have to point it to the location of the database. So in this case, the connection string here. username, password, and then potentially you can add additional properties. So Sona lets you set encoding and all kinds of other things, the type of code coverage tool you want to use, and these kinds of things. So it's actually fairly simple to integrate that. So now we ran some basic tests here. So we have unit tests, integration tests. We even have some code coverage and code metrics. Now we're kind of ready to say, well, we can assemble that thing. Before, it didn't even make sense to put it together, to even spend time on it. We knew it wasn't good at that point of time. In Java-based applications, again, that's actually fairly simple. So you can use the jar task or war task or ear task that come with the plugins, with the respective plugins. For example, you apply the war plugin, you automatically get a war task. So you simply say Gradle W assemble, and it just puts it together as you need it. Of course, you sometimes want to have more than one artifact. For that, you can set up new tasks to make it part of your distribution. One thing that I think is important, which some guys get wrong, is that they always include the environment-specific configuration. For example, database connections, URLs for HTTP calls, and these kinds of things. So try to exclude them, because remember, we want to reuse that binary artifact across the board. For production, we want to use it for testing, and we want to use it in some canary environment. So you cannot really bake in this configuration into the artifact. So try to externalize that. And there are some other tools that you can use around that, Puppet Chef and all these kinds of infrastructure tools. So they are perfect for handling these kinds of situations. They automatically sync whatever configuration you have in place, even versioned, to the specific environment. And then automatically you have the connection strings and files and properties, whatever you need in the target environment. Sometimes it's helpful to also include some build information that you can query for at runtime. For example, who built it, when was it built, what's the version number, and these kinds of things. And of course, you will have to pick a versioning strategy. People that come from Maven oftentimes go for the snapshot kind of pattern. But think about continuous delivery again, when we talked about in the beginning that we said every commit can become a potential release. That basically means creating snapshots doesn't really make sense anymore that much, because we can just assign a concrete version, because potentially we want to actually deploy this to production. So whatever you assign at the first step in your build pipeline as the version should be carried throughout up to production. You can easily model that in Gradle. So you can see we just picked a specific version for our project here, 1.0, and then some sort of build number. In this case, we picked semantic versioning. And there are some strategies that you can use to actually automatically generate that build number. It could be the Jenkins build number in your CI machine. It could be some timestamp. It could be a Git commit hash, or something that you query from the last published artifact in Artifactory. So there are different strategies that you can use here to automatically determine build number. One thing that's important here, this build number needs to be unique. So how do you do this in Gradle? Pretty simple. Every project has a version property that you can assign a Java lang object. So it's not just a string. You can actually assign an object here. And as you can see here in this example, we actually created a class in our build script, which is called project version, has a major, a minor, and a build number as field. And whenever we call these toString method here, we simply put together these attributes into the full version. And then we simply assign this to the version property in our project. Anything here can be dynamic. For example, you can see here we use an environment variable which is passed down by Jenkins. This is the Jenkins build number that I mean down there. So that is one way to model it. So you automatically get a environment variable out of the box for every job that you run.
Yeah. So in continuous delivery, you just not see need for the patch, major, minor patch?
Usually whatever you have to fix goes back into master, because you're quick and fast and you can deliver like right away. Your team isn't able to actually make this change. You might remember in the beginning when Jens said, whenever there's a problem in production, we ping this guy, he has to fix it, and then he puts the change into master, he fixes it right away, it will be pushed out. And because everything is automated, it's not a big deal anymore. So that's usually the idea behind it. Enabling your team and getting your team to that stage and changing the culture, of course, takes a while. And getting to that stage might potentially mean working on multiple branches. So if that's your use case, you can certainly do that. If you say you have a bug fix branch, yeah, that's fine. Just create another build pipeline that is pretty similar to this one that you have for master, that also takes your code change and travels through the whole build pipeline. And then you would, at some point of time, simply have to integrate it back into master. Has its own challenges because code might deviate, you might have merging issues, so it might just slow down the whole process. But that's kind of like the whole idea of continuous integration. Committed to master and integrated right away with all the other code that's basically committed. Don't have long-running branches. So I mentioned that the War plugin gives you a War task. So if you need to add anything to it, you can easily do that. Here in this example, I'm just showing you how to create a properties file which contains the version of your project. It also has the timestamp, so you can simply create this with another task, and then whenever you run the War task, you can create this property file and then simply include it here into your War file when you create it. All you need to do to actually package this guy is to run Gradle wsample. So that's hooked up into the Java build lifecycle of a project. And then once you have the artifact, you certainly want to store that in a binary repository. So again, we have a version artifact. It has a unique version number. And we push it up to any product that you might want to use. Again, the tooling option is pretty much up to you. You could use Nexus, Artifactory. You could even use a file share, but I mean, there are always pros and cons, and there's usually a good reason for the existence of these products. For example, Artifactory, you have permissions that you can set and all kinds of other things. It understands different types of repositories, so if you use Ivy type repositories or Maven style, they know both. Nowadays, they even have other types of repositories where we can even push Docker images to, these kind of things. And again, you just want to publish once, and then you want to reuse it. So this is a one-time operation for one run of your build pipeline. So you can see all these tasks that we ran through so far are part of the commit stage. It's called the commit stage because this is what happens whenever you commit code to your version control system. So that makes kind of sense. So here you can see one example. We use Gradle to actually publish to Artifactory. There could already be a bunch of versions here. You keep them in your repository historically. And of course, at some point of time, you want to clean out old versions, potentially versions that you don't need anymore. So you probably don't need the version anymore from a year ago. Because you will never have to roll back to it again if that's kind of like your fallback strategy. But that's kind of like how you do this. Again, publishing is a integrated functionality in Gradle. Here I'm showing you the use of the Maven Publish plugin. So if you use a Maven style repository on Artifactory, this is how you could do it. So you simply give it the repository URL, which we use down here. So we define a Maven repository that we want to deploy to. We give it some credentials. These credentials in this case are read from some configuration that I don't show here. And then we simply say we have a single publication, which is a Maven publication, which is the component that we create with this web project. So that's pretty much all you need to actually publish your artifact to any repository. And now you get to a point where you actually want to automatically deploy this to a acceptance test environment. You want to run some acceptance tests in an automated fashion. So you, at some point of time, want to actually be able to pull this out of your binary repository, or you still keep it around for a while in your build. That is kind of like up to you. So you can use standard dependency management to pull it back out of a binary repository. That's actually fairly simple. You store it in some temporary directory, and then you deploy it whenever you feel it needs to be deployed. Again, deployment doesn't need to happen automatically because even in some canary environment, you cannot really make sure that, that you're currently not deploying or running any functional tests automatically at that moment. The same thing is true for UAT environments. At that point of time, maybe your QA department is testing right now. You don't want to push up a new version, so it could be on request, and you want to enable your stakeholders to actually push this button and say, now I want to deploy this specific version of my artifact into this specific environment. Important point here, this needs to be a reliable process. And you can model this in Gradle. Some people use other products that are specialized in deployment or deployment processes, but you can easily model that in Gradle as well. The good thing about it is that once you formalize the logic, you exercise it all the time, because pushing to the canary environment will happen over and over again. You want to reuse the same logic for deployment for different environments. So not only do you want to use the logic for the UAT environment, you want to use this for production as well. So once you get to a point that you actually want to deploy it to production, this has been exercised all the time. It should work out of the box, and it shouldn't be a big deal anymore. So some people say, well, how do I just write some deployment code? I just want to move my file to that server, but oftentimes reality is more complex. It's usually more than copying just a file. So you have to really ask yourself, what does deployment mean to you in your environment for your application? That could mean shutting down a server. It could mean creating a backup of log files, bringing the server back up, running smoke tests. So that could all be part of a deployment process. You can model all that stuff with Gradle as well. Generally speaking, there are two different models here. So push deployment, where you simply get the artifact out of your binary repository and you push it up into the specific environment. The other model could be that there's a pull deployment, where you simply just trigger deployment on the target environment, and the target environment knows how to get the respective artifact with that specific version. For example, if you pull something from a RPM repository or a Debian, that automatically installs itself. Or nowadays, many people talk about Docker. It could also mean that you create an image or create a new container for a specific environment. So that's actually not covered on my slides, but you can see this more and more happening. You basically bootstrap the whole environment, including the deployable artifacts. So everything is set up in place, and you just start the container on premise. Just to give you an idea how you could model such a push deployment in this case. So we are using, in this case, an open source plugin. It's called the SSH Plugin, which allows you to run SSH operations against a remote machine. So in this case, we are operating apparently against a Linux or Unix machine. And you can see we can define multiple remotes here. So we have one for localhost, which has a username. It has the specific domain name and these kinds of things. But you can have multiple here. So usually in your environment, you would have probably localhost to test it out locally. You could have the dev environment, UAT, production, what have you. And then you create a single task or multiple tasks that are responsible for actually emitting these SSH commands. You can see I gave you some examples here. So here we shut down the server first, then we push up the artifact, and so on. So whatever your deployment process looks like, this is how you could model it. And you can see we create a new session, and we directly reference the specific environment, which is localhost here. But this could also be production. And you can write this in a dynamic kind of way, that based on a specific flag that you pass in on the command line, it simply picks the right connection URLs or the specific remotes for your specific session here. So you can simply say on the command line, Gradle W deploy, and then you give it the specific environment that you want to deploy to. -P, so you pass in the project property, could be test, UAT, production. And with that, you simply reuse the same deployment logic across the board. Once you deploy it, you usually also want to run some smoke tests. I'm not going to cover that. So you want to make sure that once it's deployed, it's ready to be used. Nothing went wrong in the actual deployment process. And then after that, you can basically run some functional tests. Depending on what type of application you have, the tooling might look different. For web applications, it could be Selenium, or for Android applications, it's probably something else. So I'm not actually going to dig too deep into functional testing. So usually this talk is about 1.5 hours long, so there I usually cover it, but this time it's a little bit shorter. But you can run these functional tests against each of your environments. Should be the same code again, and you can exercise your deployed application. So I was mainly talking about Gradle so far. We didn't talk about Jenkins at all. But let's bring Jenkins into play here. Let's have a look at the bigger picture here. So what we did so far is that we created individual tasks on the Gradle level, which basically represent each of the steps in the build pipeline. But now you actually want to put this together somehow. You want to form the entirety of your whole build pipeline. And you can use Jenkins. You can also use other CI servers, TeamCity. Some people even say, well, you don't actually need a CI machine for modeling or orchestrating such a build pipeline. There are other approaches to it. But I want to show you Jenkins here because it's easy to use, easy to set up, and might actually be in use already in your own organization. So again here, Jenkins, you set up a job which pulls your source code from any version control system that you use. And then with every job that you run in your build pipeline, you actually run the specific task that we talked about. We pull the artifact out of Artifactory after we published it. We deploy it, we run automated acceptance tests, and that's actually fairly simple to model. So let me show you a bunch of things on the Jenkins side to make this happen. So for each of these steps, what I did here, I created a new job in Jenkins. There has to be an initial job, which basically would represent compilation and running the unit tests. And then there are individual steps here which need to be chained together to model the pipeline. So let's first have a look at the initial job. So there are a bunch of plugins that I use here, so you can install these plugins on Jenkins. They're all free to use usually. One of the helpful plugins here is the build name setter plugin. So you will want to clearly identify what build number you have, and you want to see this in your dashboard as well. By default, you don't have that, but that's kind of helpful to render this. Down there, we have a direct integration of Jacoco to show the trend of your code coverage. So you can see this over time. If you're using Sona, you don't actually need that. Then this all lives in your Sona web dashboard usually. Yeah, exactly. Yep. And then, of course, you have to make sure that whenever the first job ran and was successful, then it triggers the build of another job. So in this case, integration testing. So we have a downstream project here, and you can model that with the help of multiple plugins, actually. One of the plugins that is helpful is the so-called trigger plugin. It also allows you to pass on additional parameters, for example, the current build number of your whole build pipeline, because you want to identify one run of your build pipeline. It should be the same number. The Gradle plugin is helpful to just basically shell off to the Gradle command. So there's an integration into the UI here. You could also run this over the built-in shell execution, but this gives you a nicer UI, I would say, but nothing else really. It also allows you to run the Gradle wrapper, not too special. And then in the end, you also want to visualize that. So there's one plugin that I'm going to show you here. It's the build pipeline plugin. And you can see for each of your executions, it actually shows the whole build pipeline. And in this case, we actually have things in parallel here as well. So it can render each of these jobs that run in parallel. They join together at some point of time. And it's also color-coded, so you can see exactly green, okay, that was okay. Red, apparently it failed. And the blue ones basically mean we didn't execute it yet. There are some other plugins that are out there. And currently, CloudBees is heavily invested in a new plugin called the workflow plugin. So they're kind of like, we need a good solution, an integrated solution in Jenkins to actually model the more complex use cases, I would say. So you could think about rerunning a specific job after it failed. So if this guy failed, simply move on from that stage. Forking and joining is a big deal, especially if you do things in parallel, and they have support for that. And how they model it, it's basically a DSL that you define, which automatically generates these jobs. There's many more. There are many more plugins that are helpful in this kind of use case to model such a build pipeline. Sometimes it's a little bit trial and error, and this might look totally different on TeamCity. It might have built-in capabilities for build pipelines, so it really depends on what choice of product you make. But that's pretty much what I wanted to show you today. Yep. That is a Jenkins plugin. So all the plugins that I've been talking about since the slide here, they are all Jenkins plugins. So you can simply install them, download them, and then you're basically done. Yep.
Yeah, just a note to people, you showed the JDepend plugin. That plugin is actually the plugin is there in Gradle, but the underlying project that it runs has been abandoned. It won't support Java 8. So it's best if you want what that plugin provides to use Sona. There's other ways to get that data.
Thanks. Yep. So I think the question is, the CI build pipeline defines individual steps. What should developers run in their local machines before they commit? Or you do have it in Gradle. In Jenkins, you simply just call off to the individual tasks. It's the same thing. Oh, I see. Well, in Gradle, you have task dependencies. So you can still model the whole lifecycle if you want to on the level of Gradle. And you usually have these things out of the box already. For example, if you run build, it will automatically run test. It will create the artifact with the sample. If you hook up your integration tests, you can create a task dependency as well. All these static code analysis tools are hooked up automatically into that lifecycle out of the box, so you don't actually have to do anything. And anything you model in your build pipeline can be hooked into the lifecycle with either like depends on or things like if you need more complex setup for integration testing, for functional tests, for example, bring up a web server first, then run my tests, and then tear it down in the end. You can model that with the API that a task gives you in Gradle.
Can you do the fork join thing in the way that Jenkins can with the pipeline plugin? Can you do that in Gradle?
So there will be parallel task execution, which is not a feature that we open up really. We have been working on it, but it's coming down the road. So this will be a built-in capability. Somebody asked me yesterday, is there also a capability to run a specific action in parallel? Just for a single task, but do multiple things at once. For that, you would have to actually create your own custom implementation for it. So if you're in the Groovy world already, there are some libraries that are helpful, Jeepers, or just general Java concurrency API to make it happen. In the long run, I think Hans also mentioned that this will become a Gradle core functionality. Any more questions? Okay, thank you very much.